What we're going to talk about today is distributed SQL, and the Cockroach DB flavor of distributed SQL, of course, will be mentioned here. But I did want to actually dive into kind of how people are using this stuff today. What are some of the challenges of doing? And then I'm going to touch a little bit on kind of how does this work in coordination and combination with things like Kubernetes as you kind of start to scale out and get more mature in kind of your cloud technology. So, but before I start, a little bit of housekeeping. Please do ask questions along the way. Charlotte is here with me. She's going to help me when there are questions. I'll probably paraphrase them, and I'll take time to do those during the webinar. Anything that we don't answer, of course, we'll send you responses to those by the end of the webinar. We will conduct a survey. Charlotte will put that into the chat at the end, and then a recording definitely will be available. But by way of introduction, my name is Jim Walker. I'm a product marketer here at Cockroach Labs. Been with the company for about 9 months, but been in the data space for really quite some time, and kind of a geek of these types of technologies. In the Hadoop world for a while, in the Kubernetes world for a while. So if you mix distributed systems with databases, that's what you got here, and that's why I'm kind of excited to be here today. So with that, I just wanted to get into why distributed SQL, right? So over the past couple of years, what I've realized and what we're realizing, and with a lot of people that we speak to, is a lot of organizations are kind of going through this complexity curve, I should say, complexity and scale curve as they're kind of moving to the cloud. I think there's not an organization that I know of, at least, that isn't moving to the cloud. Nobody's building data centers anymore, right? And what happens is people are taking their applications, they're forklifting them, VM and all, they're dumping them in the cloud, and they're gaining the benefits of the cloud, right? But what they quickly realize, they want to scale. And scaling in the cloud does actually present, some challenges. When you want to actually build out an application, or you're going to run multiple instances, most people, what they're doing today is they're breaking down these kind of monolithic applications into these kind of microservices-based applications where they can get economies of scales across simple functions or simple services, and really take advantage of the benefits of the cloud in that way, the elasticity of it, this sort of thing. A lot of people who just start off, as cloud native, or they're just building microservices-based applications, they get this from the beginning. There's still challenges. When you have multiple services or thousands of services, or lots of different things interacting with each other, they all need a persistence layer. And well, what happens when one service writes data from one part of the world and another service writes data at another part of the world, and they're all trying to write to the same place? We get these kind of, we get deadlocks, or we have consistency issues of our data, right? Just simply mounting data and talking to persistent stores in these complex applications is difficult as well. But ultimately, once we solve those things, we're seeing people then start to expand. We're seeing them to say, hey, look, I'm running in, say 2 regions, maybe it's the US West, US East, they want to expand, they want to get global, because they need business continuity. They need resiliency, they need data to be closer to users so they can actually, meet service level expectations for data being delivered to applications no matter where they are. But ultimately, I think a lot of organizations need this kind of global scale and global reach where, if I can deploy an application and have it available, a global application, and have it available across the entire world with extremely great performance times and kind of meeting all these SLAs, I think that's where a lot of organizations want to be. I mean, if you look at like the Netflixes of the world, like these organizations have nailed this, and there's very few companies that can really do that and really do that well, because they have thousands and thousands of engineers that can do that, and they can shard a database 14,000 times and still manage that thing, or 1,000, whatever that's going to be. That's really, really difficult to do. Distributed SQL came about to actually address some of these things, right? I mean, we've got lots of technologies that help us from the data, and I'm speaking from the data side of things, less from the orchestration side, right? This is a distributed SQL webinar after all, right? So we have lots of big data things, right? We've got worlds of Oracles and SQL servers and Postgres and MySQL, these relational stores. We've got NoSQL databases popped up like crazy over the past 10 years. They've been really good for getting data out to in kind of heavy read functions, right? And then, of course, Hadoop, which I was in that space for a while, having fun in that, right? There's been lots of technology. So why do we need another database? Well, A couple of things are happening. Number one, this as everybody kind of moves up this scale complexity curve, that's definitely one. The world is also shrinking. The minute you have a business, you're online, you're going to have global customers. So fight it or not, you're going to have to move up this curve eventually, right? Because that's just the nature of business today. But I really like this quote from my friend Merv Adrian at Gartner. He had a blog post just recently. There's a link here, but if you just type Merv Adrian blog post blog into your favorite search engine, I'm sure it'll come up. But cloud is the new default platform for managing data. On-premise is the past, and only legacy compatibility or special requirements should keep you there. Merv is somebody I've known for quite some time, and somebody's opinion that I respect, who's known databases and has followed this space for really quite some time. I remember having conversations with him about the cloud, say about 3 or 4 years ago, and it was still kind of far off in the distance for these traditional kind of like OLTP workloads. I think some of the OLAP stuff had already started to move because of Hadoop and some of these other things that were going on around Spark and everything else. Like the analytical stuff moved, but really heavy like read write, like has to be like system of record stuff, still not in the cloud because it was actually difficult to scale those things. I think we've learned a lot over the past couple of years, right? We can shard databases. It's kind of doing a database in a single region or within a single AZ and scaling that thing. Well, it's kind of like doing it on-prem. So the kind of same things we've learned about scale there is applicable. Doing it across global scale, though, that's a wholly other thing. And so with this move to the cloud, I think there's this added kind of requirement for something new. And that something new is, well, the topic of this webinar. And so, there's this concept of distributed SQL. I think, a couple of years ago, I think Matt Aslett from 451 kind of started to call these, there's a bunch of new databases. I think he started to call it like NoSQL, which I think it's just a hodgepodge of a lot of different things. I like to think about distributed SQL because truly, if we match distributed systems with a database, what do you get, right? Like a true SQL database. And that's what we're doing here. And that's what distributed SQL is all about. Truly distributed, not just new approaches to take legacy technology and move it, but a true new approach. And so if you're going to do this, we're going to evolve the database to be cloud native, right? To handle distributed transactions. Well, number one, I mean, these are to me the core primitive, the requirements that have to happen here, right? Number one, it's got to speak SQL. Number two, it can't add complexity because you know what? Distributed systems are already complex enough, right? It should use the scale and everything about these distributed systems and actually ease complexity for you. It should be geo-replicated, always on and resilient, which means it can actually be in multiple different regions across the planet, right? It should be resilient and resist to failure, right? It should be shared nothing like cloud native applications define, right? If you're going to go down this path, it's got to be ACID compliant, and choose your level of isolation. Here at Cockroach Labs, we like to think about serializable isolation, but it's got to be ACID. And then I think if you're going to have a distributed database, this number 5 requirement here is absolutely paramount because if you're going to have nodes across an entire planet and people are actually running transactions, just remember this whole business continuity and service, the service level agreements for performance. Location becomes extremely important because data has to actually live near your users or where it's being needed. Because a hop from Sydney to New York is about 200 milliseconds. Going back and forth across that, you're going to have seconds of delay, and that's just unacceptable. So distributed SQL's got to actually add kind of location and locality to data as well. Becomes paramount, right? And so I'm just talking about distributed SQL in the general. Of course, Cockroach DB hits all these requirements, but if we're going to define the space, I just feel like these things are really important. I think there's a lot of enterprise features that are important as well. It's got to be secure. You got to have management. You got to do like cost-based optimization. It needs to integrate with everything else you have. All those core fundamental requirements need to be there as well. But just from tackling the challenge of being distributed and global, these are kind of the key things that have to happen. So let's take a step back and talk about kind of existing technologies and how they're different from something that's distributed, right? So lots of people are familiar with Oracle, right? If we wanted to actually have a redundant system, we're using Oracle. We're using Oracle RAC. We're using Golden Gate. We're doing some sort of asynchronous, synchronization of multiple different systems. Kind of legacy tech for kind of legacy systems. And I think this was state of the art and is fantastic. It's fairly expensive and difficult to configure, but it works, right? It works. You have it in your data center, maybe 2 different, You have this redundant system, you know, it's kind of active passive. It's costly. It's fairly monolithic approach. Then came about, you know, things like Aurora, and Aurora is about 2 or 3 years old. Initially built for a single data center, right? Built for single region. They took Postgres, and what they did is they ripped out the storage layer underneath, and they said, let's give distributed storage and have multiple instances of Postgres on top of this. And then each one of those instances of Postgres will be able to access that data because it's distributed. And I have this really nice thing. And then they're able to do asynchronous replication between multiple different regions, right? And so with Aurora, you can have like, yeah, you can have 2 regions. I don't know if they've expanded to more than 2 regions now, but last I checked, you can have, you know, an instance of Aurora in 2, but you're still going to have a write node in 1 region. Now, that's not a fully distributed database. You're distributed on the read side. Sure, you bet. Like we have read replicas. You're doing this kind of async replication between the 2 systems of distributed storage, but it's not fully distributed because we don't have distributed writes either, right? And so this is kind of legacy tech that's actually taken advantage of the cloud, but in a new way. Built really for a single data center. Now, where we get to really a wholly other level is this kind of, you know, globally distributed, where, you know, we have this geo-distributed nodes that participate in a coordinated database, where one goes down, you still have access to data. We can bring RPO down to 0, which is incredible. And it's architected from the ground up. We didn't take, I think the new distributed SQL databases, they didn't take existing technologies and say, hey, let's make these things distributed. You kind of got to build from the ground up to be cloud native. If you're going to be cloud native, you got to be built for the cloud. And that's really kind of that is really truly the difference between kind of the monolithic, these kind of legacy techs, which are kind of like single region, maybe do 2 regions, and then fully globally distributed. So just to give context, using some existing technology of how these things work, I'll jump into kind of how we then are architected, right? Cockroach DB is unique in its architecture in that, you know, each node, as I noted before, is a single instance of this database. Every node that participates in this global cluster is a single consistent gateway to the entirety of the database. But every node you could think of as just a database. It comes with everything that you need. It could function alone on this laptop that I'm running this laptop without anything else, without any other nodes. It would be I don't have components of, you know, write over here and read over here, or like storage manager over here, or transaction, you know, function here. It's actually in the entirety a complete database, and that's integration, all those things that you actually have to be a database, right? If you're going to have an enterprise database, you got to have these things. And so we've gone to long measures to take care of these things, you know, adding things like change data capture, you know, building a cost-based optimizer, which I think is one of these kind of core capabilities that, you know, when people think about traditional databases, is a really important thing, right? You know, being able, you know, a management console. Actually, we tweeted last week, if y'all want to check out the management UI, there was a tweet on our Twitter feed. I should get that. I'll send it out. If you wanted to check the UI, right? And so we basically, all these things are available, right? Where it gets different is this dark blue box here called global coordination. So everything the traditional you would want, what we can do is basically, we can spin up a node, which was kind of represented as this kind of, you know, single green little, you know, cylinder over there. We could spin up a node anywhere, point it at a cluster, and it's going to participate in a distributed cluster and a distributed database. Now, what we're doing is we're actually coordinating and gaining consensus for all queries and transactions, because if you're going to have a node living in London, or 3 nodes in London, you're going to have 3 nodes in Oregon and 3 nodes in Sydney, and everybody's writing to the same database and you're writing to the same exact record at the same time. Who wins, right? You got to actually coordinate that. We can deal with the replication and repair. We automate all of that, right? We'll talk about that a little bit more. And then attaching location to data is actually really, really important as well. And those are kind of the core capabilities that we're doing within the database that are very different than a traditional database that sets apart distributed SQL from some other things that are out there. And then ultimately, this is going to be inherently multi-cloud too. We'll come back to that as well. But let's just talk about scale. You know, in distributed database, again, we just spin up a node, we add it to the cluster, and Cockroach DB actually automates the rebalancing of data across the entirety of the cluster, right? So you're always going to have kind of an even utilization of the data, right? And so, you know, there's 3 laptops in the room right now here where I'm sitting. Let's say each one of them was a node in a Cockroach database cluster. If we spin up another node on another laptop, I bought into the room, we point at the cluster, it's going to evenly distribute that data. right? We're writing data in triplicate across a cluster so that we can actually, maintain these things. And that's how we get quorum. That's how we get consistency. More importantly, it's how we actually get a resilient database as well. If one node went down, we're still guaranteed to have 2 copies of that data on other nodes, right? And this is where we get to this RPO of 0, because any node in the entirety of the database is actually a gateway to the database, right? So it can find all the data no matter where it's stored, right? And so, and if we lose a node, it's, the database is smart enough to understand, well, I've lost one of the copies, the 3 copies that I had, I better create another version of that copy somewhere, right? And so we have this way of kind of efficiently dealing and very gracefully dealing with, say, a failure of a node. Now, anybody here who's familiar with things like Kubernetes will be very familiar with this concept in that, when something goes down, it's got to come back somewhere, right? That's what etcd kind of maintains for you a certain state. So it's kind of aligned very well from that point of view as well, right? But if you think about it, it kind of eliminates the need for these active passive systems. Yeah, we can still do distributed backup or restore, these sort of things, but it removes the need for having these kind of big box kind of active passive things going on and removing and shrinking RPO down to 0, right? So if you're also going to do a distributed database, again, global consistency is really, really important, right? We don't need records to write over each other. With Cockroach DB, we actually implement serializable isolation. This isn't snapshot isolation. It's truly like the highest level of serializable, so that you're certain that the data that's in your system of record is going to be correct. And that really lends to the next part of the conversation I'm going to have around, like, where do we fit? And we're really good at these kind of heavy read-write transactional workloads, because we're going to protect you from things like write skews and dirty reads, right? It's going to make sure that every transaction looks like it's happening serializable end to end, right? And so we've gone a long way in our build out of a database. We've been at this for about 4.5 years. A lot of time has been spent on the last kind of 3 things I've talked about in terms of, being able to automatically rebalance things, being able to automatically repair, distribution of data across the entire cluster so it's easy and it's efficient. More importantly, this consistency. When you're doing transactions in a distributed environment, it's extremely complex. This isn't a single database where I remember semaphores. Geez, you just put a lock on a row and write it. No, you have this row written all over the place, right? And so how do you take care of those things? And so we've gone to great lengths, and doing this for 4.5 years has allowed us to kind of identify all the corner cases where it's just really difficult to find all the nuances and issues you're going to have. And so we take real deep pride in this part and in this technology here, because I think it's one of the most difficult problems to solve is consistency in a distributed system. Now, the last bit, and this is somewhere we stand out a little bit different than others, is being able to tie your data to a location, right? We can take data and we can say, okay, look at all the records that are of German in origin in our customer table. They need to live in Germany, or records that are Californian need to live in California. Whatever that is, from a compliance point of view, that gets really interesting, right? I think people look at us, they don't need to code that into the application layer anymore. They can use the database to actually segment and understand. Geo-partition is what we actually call it, data at the row level and tie it to a particular location, right? Because we have nodes and we know where they live, we can name them, we can do whatever we want with them. We can do things like tie data to explicit clouds. If I spin up a node of Cockroach DB in one cloud and another and point at each other, it's going to be one database, and now I can actually at the row level tie data to very particular places. But I think more important, it really comes back to the kind of how do we reduce latencies. This is what allows us to do things like allow data to follow a user, so that we can ensure these great performance expectations no matter where somebody is actually accessing, say, your application. But if you're going to be a distributed database, knowing that data is going to reside all over the planet, well, it's actually pretty important to take that into consideration, and that how you store that data, you're actually moving it to the most optimal place where that is. We do a lot in Cockroach DB to take care of this. If anybody here on the phone is familiar with Raft and Raft leaders, we're actually moving Raft leaders to where where data is being accessed most. There's some really deep intelligence there. I'm not going to get deep into it. I think Peter Mattis on our last webinar went into the architecture, or the kind of deep dive architecture. That's a pretty good webinar, and I'm happy to have follow-up questions around those things. In the next conversation, the next webinar, we're actually going to be talking about topology. So, like, how do you deploy this thing, and where do you put instances, and how do you configure things to actually optimize these sort of things around performance, right? And so we're going to talk about that in our next webinar. This is more a little bit of a high level one, right? This is going to be, it's just one product marketer and some slides. Sorry. Again, though, this is inherently multi-cloud. Again, I could spin up a node anywhere, pointed at a cluster, and it's going to participate. I could spin up a node right here, and if I already had a Cockroach DB cluster running off in US East down in Raleigh or whatever that is, right? It would participate, and the database would start basically balancing. It's just as long as I have a TLS connection into that cluster, I'm good, and I could participate. So we could do something very unique in that we can have a single database span multiple cloud providers. So truly multi-cloud, and then hybrid, of course, as well, right? So where is this sort of thing used? We get asked this a fair amount. Ultimately, Cockroach DB and distributed SQL in general is typically really good for these heavy read-write distributed transactional workloads. So these things that are a system of record, but a heavy read-write, mostly heavy, like the more write, even better. Like these deep entrenched transactional kind of relational workloads that we've been thinking about for years. A lot of organizations come to us because they're modernizing. They're moving to the cloud. I hear that just basically every day, all the time. They want to get off the mainframe, or they don't want to be beholden to a legacy database provider because it's expensive. They want to move on. They have these kind of monolith to microservice, initiatives where they want to break down these massive applications into microservices. And I think it's a kind of a unique one as well. I worked at a data integration vendor, and there's lots of ETL out there. Well, sometimes we're doing ETL just because we need to move data from one instance of a database to the next. And who cares if it's synchronous or asynchronous replication? It's just like, we're just moving. Can I actually shrink multiple instances of a database together and now let the database just automate the distribution of this data? That's another area where this is kind of happening. And then, ultimately we're seeing that on the kind of modernization side, but, a lot of organizations are adopting this sort of technology for net new applications. And I will encourage everybody out there, if you're going down the path of, building out microservices-based applications, you're going down the path, yep, we have this new project, it's going to run on Kubernetes. I would highly encourage you to look at a distributed database as opposed to a traditional database because of the issues of scale and some of the things that I've already talked about. And this is really built for this new world of kind of distributed systems. It's distributed SQL after all. But it's really good for things like, your system of record, like financial services type stuff, financial record or a book. I'll get into an example of a customer next. Inventory that's got to be right across multiple different locations. A metadata layer. Lots of people use this for this geo-partitioning feature we have. They just, actually on the modernization side, one of the things I think we're seeing a lot of people, they just don't want to shard a database anymore because it's so complex. And so we're seeing organizations actually use us and use the distributed nature of what we're doing to actually take care of all that sharding because we just automate all that. And then of course, I spoke to it on the location stuff, but the regulatory compliance stuff gets really important as well, I think. A lot of organizations, especially in the EU right now, it seems that GDPR has a fair amount of teeth, actually. So there was a question here about let's see here, about spanner and atomic clocks and quorums and all these things. Yeah, so great question. Let me just address that really quickly. Cockroach DB is actually modeled after the original Spanner white paper. So, kudos to the engineering team at Google that actually built out Spanner because it's really kind of remarkable. What they've architected and what they put in that white paper is truly amazing. In fact, the founders of this company, Ben, Spencer, and Peter. Oh my God, I almost forgot Spencer's name. How could I do that? So Ben, Spencer, and Peter, they're kind of original Google people. I think it was, they were very early days. They actually helped build out Colossus, which is the file system, and ended up building lots of different things. So they were kind of living in that world as well. And so they've, this database is really modeled directly off of that. Now in Spanner, they use something called an atomic clock, which is it's kind of a piece of hardware that's in each server that's running Spanner that allows them to basically synchronize the clocks. You need to synchronize clocks to get consistency in a database because time is really important when you want to be serializable for your transactions, right? They need to happen in order. We actually use NTP, which is the network time protocol, and then we actually have built out software that actually allows us to correct that time over time as well. So we don't need specialized hardware, and we're still getting very good results on any sort of hardware, on any general hardware, and we can do it all basically in software using NTP. And so that's how we get past that, and it's absolutely efficient and works perfectly well. So, yeah, so I'll come back to that question as well, Charlotte. Thank you. So let me just give you an example of a customer who's using this. So Kindred Group is an organization. They're run out of Stockholm, one of my favorite countries on the planet. They are an online gaming group. They have 20 million customers. They do business in places like Denmark and Ireland, but also down in Australia as well. They're definitely microservices driven, large organization. Now, they are online gaming. They have significant issues around compliance, right, and regulation of customer data. They do a lot of business in Europe. Latency is incredibly important, especially when you're doing online gaming. If I make a bet, it's got to happen. Like, I can't have any issues. And then if I make a bet, that thing better be booked, right? Like resiliency. I mean, like online gaming is stringent from a requirement point of view as a bank, if not even more, because things need to happen in real time, right? And so, you know, they have challenges, and they've been building out systems for years, basically try to meet these things. But they're also scaling their organization to actually into new regions as well. And as they scale, they look to Cockroach DB to be a new database for them. So they had a system of active passive in each region, you know, running in, you know, a couple different data centers across the planet. You know, this replication of data, it kind of wasted resources to them. And then basically the movement of transactions between various different locations was kind of serializable and a synchronous replication or asynchronous replication. So it wasn't done in really real time. Each region kind of almost worked as its own deal or as its own kind of like instance of everything, with nothing really kind of being kind of combined and working together. Now, they chose to use Cockroach DB to really tie all this together. So they have one virtual, basically, database, one distributed SQL database for all global transactions. This really kind of reduced latencies across regions and had huge effects on compliance as well. They were now able to have a single database with all this greatness of lower latencies and, you know, better utilization of resources, yet still meet the requirements of being able to tie data to a particular location. And then this whole replication was another piece of this. I mean, the resiliency and being able to actually have things available at all times was critically important to them. You don't want to actually have to say no to a bet because that's money. And again, transactions and online bets, they have to be right? And so the consistency thing was really, really important. So it was definitely scale, right? They needed resilience. They'll come back to scale. There's definitely resilience. It's got to be up all the time. Consistency was hugely important to them because it's online betting. It can't lose money here. And then locality became really important from a compliance point of view. Now, from a scale point of view, it became really, oh, this is the resiliency slide. Sorry. Scale is actually really important as, you know, I think Kindred starts to look at other regions of the world who actually, you know, legalize online gambling and these sort of things. Well, it's real easy for them to actually just spin up a new Cockroach cluster, and here they go, you know, spin up their app in that region, and they can get going fairly simple, and it kind of eases their whole approach to scale. And so Cockroach at Kindred has been a phenomenal customer for us, and we're very thankful for them for everything they've done and helping us kind of build out what we're doing. They've been great helping us with requirements along the way as well. So I just had to thank them profusely. So finally, there's Cockroach DB and Kubernetes. Now this, you know, Kelsey's wonderful, and Kelsey sometimes says some things that's really nice about Cockroach DB. He's had a couple. This one in particular I love. Kelsey Hightower, he tweeted out, it was about a year ago, Cockroach DB is the spanner, what Kubernetes is the Borg. You know, Kubernetes and Borg, you know, Borg being the internal version of Kubernetes, basically. Spanner being the internal DB, basically. And then Kubernetes and Cockroach. So there's a real common fit here. This is a very common distributed architecture. What we're doing in Cockroach DB is a very natural fit for pods and orchestration. In fact, the same resiliency, the same kind of way that we actually manage, you know, compute is kind of the same way that we're managing, you know, the database itself. So there's a really good fit here. There's a Helm chart that eases deployment. We can actually do multi-region global scale. which I know from a federation point of view is still a little bit difficult from Kubernetes, but we can actually take care of it from the data side, which is actually really, really important. And then, geotagging for us actually helps us kind of, drive, maybe that's actually helping where compute actually needs to spin up within a Kubernetes cluster as well, right? And so, for us, we're simply just another database. We use a storage class to basically mount and then use that within your pod to access the database itself. Now we are using stateful sets for deployment because that actually allows us to get better control on how things are deployed. So if you're familiar with Kubernetes, if you're familiar with stateful sets and Helm and everything else, it should be pretty straight. And the storage class, oh my gosh, it's really, really important. It should be pretty easy and straightforward, right? Because Kubernetes is allow you to orchestrate compute within a region, right? You can scale it up and down. You sure things are always on, right? It's really good for it has challenges on these broad geo-distributed kind of regional configurations, right? So typically what people are doing are bringing up a Kubernetes cluster in each region, right? And it's kind of hard to actually have one Uber thing kind of on top of it. We can actually provide that from a data point of view, though. We can actually live across multiple different Kubernetes clusters, yet still provide a single database across all those things. And so it's a little bit more of a complex implementation. This is a topology pattern that again, we're going to talk about in our next webinar. It's actually pretty interesting stuff, but it's going to scale up and down just like your Kubernetes. We did a webinar, I think, 2 or 3 webinars ago, my friend Tim Vail and I, where we had a Kubernetes cluster up and running. We started killing off pods, and well, Kubernetes bought the pod back, and the pod was smart enough to bring back Cockroach, and everything was rebalanced and no outage, right? It was just kind of like the same sort of architecture. That resiliency kind of demonstrates very well. And then the whole concept of rolling upgrades is interesting too. I think, and one of the cool things about Kubernetes is that with Cockroach DB as well, if I simply just shut down a node and bring it back up, well, when I shut it down, the database is smart enough to know that I only have 2 replicas of the 3, so I better create another version of that replica. Okay, great. But then when that thing comes back on, it rebalances everything. We actually do rolling upgrades in Cockroach DB as well, very, very elegantly. And it's kind of a core feature of what we're doing. So with that, I want to wrap up. I'm just over a half hour. I'm at 30 minutes exactly. So this is cloud neutral. Again, this allows you to build across multiple accounts or open source. It is available. This is an opinionated point of view in terms of what we're doing. It's actually all coded in Go. And it's available today. You can go to cockroachlabs.com today and go check out what's interesting for you. The core version is free to download, and you can start doing this. There's some amazing documentation. Our docs team does a great job. There's some good tutorials. It's pretty simple to get it up and running. I think everybody, and even our marketing team, has gotten a 3-node cluster up and running on their laptop. So if us marketers can do it, oh boy, right? We do sell an enterprise version of this where we add some features like some of the capabilities around CDC, some of the security features. We're happy to talk to you about that. And then we have a managed service offering as well, all available off of our website. And we'd love for you to go down and use that today. So with that, I'm going to have a quick look here to see any other questions we have. When can we expect to see the major cloud providers offer Cockroach DB as a DB as a service? That's a great question. I don't know. Right now, we're pushing really hard to offer ourselves as a service. We are more than happy to have conversations with the large cloud providers in terms of offering Cockroach DB as a service. And we're pushing right now to push as many people as possible to start to use it. We really believe this is the architecture of the database of the future, and we think it'd be everywhere. So. Are all the regions of Cockroach DB need to be connected to each other, or you can connect one region to another and another increase the latency to have the same data everywhere? Okay, so this is so basically, can I have one region only connected to another region, and then that region only connected to one more region? Actually, with Cockroach, as long as you have a TLX connection to the entirety of the database, you have access across all regions. What we do, though, in terms of basically moving data or having certain data live in particular regions, that's where geo-partitioning comes in. So again, this is a topology question. We're happy to talk about that. I know our next webinar is going to be about topologies. So typically, once you connect to a cluster, you're connected to the entirety of it, and that's really a value of the database in that every single node within Cockroach is a single consistent gateway to the entirety of the database. But then again, you can geo-partition the data off how you wanted it to. So All right. So with that, that was all the questions. I guess this is fairly straightforward. I hope it was valuable to everybody. Again, you can go download it today. We're going to have another webinar here, I think, at the end of the month about implementation topologies. We do have a survey that we're actually going to dump into the chat. If everybody could do that, we do want to make these things better and better all the time. If there were any other questions that I missed that because they were in another area, I will make sure to answer those as well. And with that, I need to thank everybody for taking the time today. I know that that time is precious. Thank you for listening to us talk about distributed SQL and how Cockroach DB has built this out. So at 1:40, I give you back your 20 minutes. Thanks for taking the hour, everybody, and have a great day.